Hi everyone, Mrs. Raposa here. I'm going to do example 10 from the 8.2 notes with you. We need to solve the equation 6 times the sine of 2 times what angle measure is equal to 5. And we're going to solve for all the angle measures x between 0 and 2 pi. This equation right here actually has 4 solutions between 0 and 2 pi. It's a little different. First, let's divide each side of this equation by 6. If you divide this side by 6, you're just going to get sine of 2x. If you divide this side by 6, you're going to get 5 6. So I divide each side of the equation by 6 first. If the sine of 2 times the angle measure I want is 5 6, that means that the sine inverse of 5 6 is going to equal 2 times the angle measure I want. So the sine inverse of 5 6 in this case is equal to twice the angle measure I need. Let's take a look on the unit circle and see where the sine is actually positive 5 over 6. That's going to happen in quadrant 1 and in quadrant 2. This angle measure is going to be the sine inverse of 5 6. Let's make sure my calculator is in radian mode, and it is. And I'm going to do the sine inverse of 5 6. That gives me about 0.985 radians. So 0.985 radians is equal to twice the angle measure I want. I'm going to put 0.985 here. But 0.985 in this time is not the angle measure I'm looking for. It's twice the angle measure I'm looking for. The other angle measure over here in the second quadrant, remember this is 0.985 radians too, if the y-coordinate here is the same as this y-coordinate. This angle measure is also twice the angle measure I'm looking for. And this angle measure is going to be pi radians minus 0.985 radians. So pi minus 0.985 is also equal to twice the angle measure that I'm looking for. This one is easy. 0.985 equals 2x. I'm just going to divide each side by 2 to get the angle measure I want. And that gives me about 0.49 radians. So one of the solutions is about 0.49 radians. To get this solution, pi minus 0.985 is about 2.16. So 2.16 is also equal to 2 times the angle measure I'm looking for. Divide each side by 2, and I get about 1.078, so about 1.08 radians. So those are 2 of the 4 solutions. I'm going to show you why there's actually 4 solutions. There's 4 solutions because the period is not 2 pi. The period is actually 1 pi. Remember that 6 times sine of 2x, if I were to graph that equation, y equals 6 times the sine of 2x, this is a times sine bx. A is 6. That means that the amplitude is equal to the absolute value of 6, which is 6. So on the y-axis, this graph is going to go from negative 6 to positive 6. Since b is equal to 2, I'm going to put it over here, the period of this function is actually 2 pi over 2. So the period of this function is pi. That means from 0 to 2 pi, there's not just one cycle of the sine wave, there's going to be 2 cycles. One cycle is going to take place from 0 to pi. So the sine wave begins at the origin if it's not being shifted up or down. It ends where the period ends. In this case, that's going to be pi units on the x-axis. Right in the center, there'll be another x-intercept. So those are the 3 zeros of the sine wave from this function. In between these two, I'm going to have a maximum of 6. In between these two, I'm going to have a minimum of negative 6. So there's one full cycle of y equals 6 times the sine of 2x. I can actually do another cycle. This is going to repeat itself here. So again, 1 and then 2. In between these two, another x-intercept, just like I had here. In between these two, a maximum, positive 6. In between these two, a minimum of negative 6. And as you can see, the graph of y equals 6 times the sine of 2x actually has 2 cycles. from 0 to 2 pi. This is the graph of y equals sine 2x. Y equals 6 times the sine of 2x. The other side of the equation is 5. So let's graph the equation y equals 5 and see where these two graphs intersect. Where does 6 times the sine of 2x equal 5? Right here, 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 and here. There's 4 solutions between 0 and 2 pi. This is pi, 3.14. This is half of pi, so 3.14 cut in half is about 1.57. That's not one of the solutions, though. My first two solutions, where these two graphs intersect, the left side and the right side, are at 0.49 comma 5. When the angle measure is 0.49 radians, the y-coordinate is 5. And this is 1.08 comma 5. A little less than 1.57. So those are the first two solutions. To find these two solutions, I simply add one full cycle, one period, to these two solutions. The period is pi. From here to here, I call these the way up solutions, the solutions on the way up, right here. The distance between this on the x-axis and this on the x-axis is pi units, because one full cycle happens in pi. So to get this solution, I take the x-coordinate here, 0.49, and just add pi to it. So this third solution will be 0.49 plus pi. And the way down solution, the solution on the way down of this wave, that's the distance. This is another way down solution. On the way down, I get this intersection. From here to here is also a period of pi units. So I'm going to add pi to 1.08 to get the fourth solution. So that means that my third solution is 0.49 added to pi, which is about 3.63. And the fourth solution will be pi added to 1.08. Which is about 4.22. So those are the 4 solutions from 0 to 2 pi.